Good morning, everybody. It is 6:25 a.m. and I am recording Unit 1, Day 6, Polynomial Identities. Okay, in this unit, we're going to verify a polynomial identity. We cannot use properties of equality to solve, meaning we cannot move things from the left side of the equation to the right. We're going to be using operation properties such as commutative, associative, distributive, and algebraic manipulation on each side of the equal sign separately. Okay, what the heck do I mean by that? Let's take a look at number one. Okay, so number one, we want to verify the identity. What I want to show is what I have on the left side of the equation is equal to the right side of the equation. Okay, not our usual way of typical solving things where you move variables to the left side and you simplify as is. In this case, all right, we're going to be showing that the left side, this x squared, okay, can equal what we have on the right here. Okay, so let's first look at this piece right here. Okay, now we're kind of working backwards in comparison to what we've done in the previous units here. Okay, but this is an example of a dots problem. Okay, all right, this is actually a difference of two squares already factored out. So let's move it back. Let's go back the other direction. So x minus 5 and x plus 5, okay, there's a couple ways you could go about it. We could multiply these pieces out. Okay, so you would have x squared plus 5x minus 5x minus 25 plus 25. Okay? Or you could just simply recognize that these two things multiplied together is equal to x squared minus 25. Okay? However you want to go about it. All right? But this still works. Doing it this way here. So let's see what cancels. I know this 5x and this negative 5x cancel. And then I also see this negative 25 cancels with this 25. And so what do I have left? I got x squared and x squared. And is x squared equal to x squared? All day. All right? And so there we are done. Okay? So in this unit, again, we are not trying to isolate variables like we would in a typical problem like this. X or 3x plus 5 is equal to 6x minus 7. Okay, we would try to get the x's together, get the 7 and the 5 together, isolate x and solve for x. Okay, we're not doing that in these problems here. What we're doing is we're manipulating each side of the equation separately such that we get the same thing on either side. Okay, so let's look at number 2. Show that the following is true for all values of x. Okay, so I want to show that the left side of the equation is equal to the right side of the equation. All right, and so how do I want to do that? Well, let's take a look. I think I'm going to use factor by grouping and try to make the left look like the right. Okay? So I'm going to factor by grouping on this left side here. So I see 4 terms, so I'm going to take out an x squared. Okay? What do I have left? X minus 2. Okay? I'm going to take out a negative 4 in this piece here, and again I'm going to be left with an x minus 2. So I'll equal to x plus 2, x minus 2 squared. Whoops. Hit a button. Okay. So let's isolate this thing right here. X minus 4, x minus 2 is equal to x plus 2, x minus 2 squared. Okay. Now, if you haven't picked up on it already, right here is a dots problem, right? Which means we can separate this thing to x plus 2, x minus 2 is equal to x plus 2, x minus 2 squared. Okay? And finally, if you haven't seen it already yet, we have x plus 2, or x minus 2 times x minus 2 twice. So if you think about that, if I had 6 times 5, right, would still be the same as 6 times 5 squared. Right? We can all agree with that, hopefully. And so going back to this problem on the right here, okay, I have an x plus 2, but notice I have this thing being multiplied by itself twice. So therefore, I can write it like this. Okay? Or if you're not fully convinced, maybe leave this right side as is and just expand that other side. Okay? Either answer is okay. Right? We usually, us mathematicians, prefer this one, okay, because it looks a little sharper. We've got less parentheses floating around. Okay, but I would accept both. Okay? All right, let's look down at number 3. Number 3, okay, might not seem obvious at first, okay, but this is another example of a dots problem. You're probably thinking, what? Where in the world are you seeing that? Okay? Ignore the fact that we have an expression here. Okay? We don't know what x and y is. Okay? But I'm guaranteed, though, if we ever added them together, if x was 2 and y was 3, okay, we would add those things together, 2 plus 3. And then what do we see in the corner? It's also being squared. So I know that whatever numbers go in there for x and y, okay, they're going to be added together, and they're also going to be squared. So if in this case, do we have some number squared? Sure do. We have another square number here, a perfect square. 3 times 3 is 9. And then I also see a subtraction sign in the middle. Okay, so what that tells me is I have a difference of 2 squares. Let me get rid of that. Okay, so our a value here is x plus y, and our b value is 3. Okay, and so remember, difference of 2 squares looks like this: a plus b, a minus b. So in this case I got x plus y squared minus, I'm going to change this to a 3 squared, right? Because 3 squared is just 9. And I'm just going to fill in x plus y plus 3, x plus y minus 3. Okay, and now we have just shown that these two things are the same. Okay, so again, what we had to recognize here is even though we see an expression here in this first set of parentheses, okay, as long as it's in parentheses and being squared, whatever x and y are, they're being added together and being squared. So we have some number squared minus some number squared, difference of 2 squares. Okay, let's look at number 4. Okay, so we want to verify this identity. All right. How can we go about this one? Well, I'm just going to kind of roll with it. All right, so I know from that last problem, okay, this is also a difference of 2 squares. Okay, I got some number squared minus some other number being squared. Okay, don't be scared by the expression inside the parentheses there. Okay, it's still just some number being squared. Okay, so let's simplify that guy. So I'm going to go 3x plus y. Right, don't forget a squared minus b squared is equal to a plus b and a minus b. So in this case, our a is what we have in here, and our b is what we have in that parenthesis. So I'm going to go a plus 2y in parentheses and a 3 plus y minus b. Okay, so we got a plus b, a minus b, and now I'm going to do some simplifications. Okay, so I'm going to have 3x plus 3y. Let me get rid of the parentheses here, so maybe it might look a little clearer for you. All right, so I get rid of the parentheses. Okay, that side. And this side here, okay, just remember I have to make that 2y negative. Okay, so now let's add these up. Okay, so I got a 3x. 1y plus 2y is 3y. And I have, again, a 3x. And y minus 2y is negative 1y, or just y. Okay, and now, in this piece here, I'm going to factor out a GCF. So I'm going to have 3x plus y, 3x minus y. Okay, now I've just shown, right, that this left side of the equation is equal to the right side of the equation using algebraic manipulation. Let's move on to the last one. Okay. Again, this one looks super intimidating, right? Let's take a look at what we have here, though. Okay? I see some number, a and b. All right, we don't know what they are, but added together, they're getting cubed. Okay? So I got some number cubed minus 8 is also a perfect cube, right? 2 times 2 times 2. So here we have a difference. Whoops. Difference goes with an I. Difference of perfect cubes. Okay. So our a value here is just a plus b. Our b value is 2. Now remember, difference of 2 cubes looks like this. All right, and so let's just fill in our a's and our b's here. Okay, so let me write this over to the left. So I'm going to say a plus b minus 2. I don't think I gave myself enough room. I better move this over. Move this over too. Okay, so let me actually, I'm sorry, I'm going to write this down here. So, a plus b squared plus a plus b times 2 plus 2 squared is all equal to, let's see if I can squeeze it all in here, a squared plus 2ab plus b squared plus 2a. Boy. Plus 2b plus 4. Phew. All right. So I'm trying to show this left side is equal to the right side, and I'm almost there. All right, so let me take out some parentheses in this first one, okay, because I don't need those parentheses in between the a plus b and the negative 2 anymore. All right, now, a plus b squared, okay? If you look at the top corner here, I'm going to do that for you real quick. we have to factor this guy, right? So a times a is a squared, a times b is ab, b times a is still just ab, plus b squared. Simplify, we get a squared plus 2ab plus b squared. Okay, so that's what I'm going to have in the beginning. That's what this piece is equal to. Okay, when you square that piece out. All right, I'm going to distribute this 2 into this set of parentheses, so I'm going to have a 2a plus 2b. And finally, 2 squared is 4. And I'm not going to rewrite all that on the right here again, because I'm going to run out of room. But this left side, I just shown this left side is equal to the right side of that equation. Okay, so that is polynomial identities. For homework, there's 4 problems. I want you to try all 4. Okay, make sure to bring your questions to class, and good.